In this lecture, we'll talk about managed memory and GC, their relationship together. This is going to be very important going forward, like I say, with all of the lectures in this course. But GC is extremely important to understand, and I'll try to explain what GC is to the best of my ability in this lecture. Let's dive in. So, what is garbage? We can actually relate garbage in memory to the actual garbage in our homes. Okay. So, let's say we eat candy, we eat the chocolate and then throw the wrapper in the dustbin because we don't need it. Now, do we immediately clear our dustbin? No, right? We just throw it so that when it's convenient for us, we can clear the dustbin. Okay. So let's say this dustbin is now this much big, and now we find it convenient. Hey, we have enough time to actually go outside and clear our trash. So we clear our trash, and now the trash is empty. This is essentially how garbage works in PC. Let's say we have a memory. Okay, let's write code here as well. We earlier talked about it. Let's say we have a boss E. Okay, this is a reference, not an actual object. When we say E equals new boss, then an actual object is created, which is going to be much bigger in size compared to the reference. And the reference points to this. Okay, a reference is simply a pointer. This E thing is a pointer. Now, there's a problem with this way of writing code. E equals new boss. We overlooked this in the previous lecture. That is because of teaching you the concept. Like, if you are creating a new game object, equals new boss will not work because this only creates a C# side of the code, meaning it's no actual game object. It's just an instance of memory. You don't have things like transform or mesh renderer or things like that. If we want a new boss to be present in the game, instead of doing this, we need to say E equals instantiate boss prefab. Okay. Now E is correctly linked to an object. Okay. I hope this makes sense. Now, there are a few ways to lead to garbage. One way is to actually destroy. Destroy doesn't cause garbage directly, but the second way is to set things to null. Okay. There may be other ways as well, but let's focus on these two things. When we say destroy, right? What essentially Unity does is there's a reference and then there is an object, right? Like I said before, if you write equals new boss, this actually creates only a C# side of the object. Okay. But it doesn't actually create a game object that we can place in the world. We do it by instantiate. So there's actually a native part of every game object and a C# or managed part of every game object. The native parts include all the Unity stuff like transform, rigid body, particle system, all of those things that are Unity stuff. Now, what do I mean by the C# side? Now, this may be confusing, but let's say in the inspector you had transform, rigid body, and then your player movement, or let's say in this case for boss, let's say there's a boss script, right? So in order for script to be an actual component, for every C# script, there's actually a C++ equivalent, okay, which is native. This is how we add scripts, basically, okay? There's a C++ object that runs in the background. When we destroy a game object, we destroy all of the native part and we destroy the C++ part. The C# part remains, okay? And then after a while, this essentially marks the C# as something that is destroyable, and then it sets this to a fake null, okay? Not an actual null, but a fake null, because we can still check if the C# object is still null in our code, and that may create errors. So we set it to a fake null, and then after a while, we clear the trash, we clear everything. So now that's how destroy works. I hope that makes sense. So every object has a native and a C# side. The C# side, meaning your code, also contains a C# side and a C++ side. And C++ side is actually in your native part. So you can't technically call it C# side. It's still native. Your script also contains a C++ side to it. That is being destroyed. But the C# side is set to fake null when you're calling destroy. Now, when we directly set this boss E, which I should have written it B. I don't know why I've set it to E. If we set it to null, we just eliminated this arrow. That is another way to do it. Now the garbage collector is responsible for figuring out, hey, what is unused memory? Now you can see that this instance was previously used, but now it's no longer used. So the garbage collector will clear this memory for use later. Okay. What essentially is garbage? These things. This is an unreachable object. This is garbage. Okay. Not this one. This is still written in code. But this one is the new boss, or the C# part of E. This is unreachable. So this will be null. But this doesn't destroy the native part. I hope that makes sense. Okay. If you have an actual game object that you need to be destroyed, destroy is the way to go. But let's say if it is something else that is like player stats or something that is equals new player stats, which only needs a C# side, then you set it to null, which is the better way to do things. Okay. So these are two different ways in which we can create garbage and we can eliminate things in memory. Okay. I hope this is clear. So garbage is essentially unreachable managed objects. Now, garbage is not leaked memory. Leaked memory is a completely different concept that is also coexisting with garbage spikes, which we'll also look into it. Leaked memory is more dangerous because they are invisible. You need to be very observant to figure it out. Garbage is something that the profiler actually shows us. So it's a lot more direct. Leaked memory is a much bigger concern, which we will talk about in this course. Okay. Garbage, you might be here for GC, but there's a much bigger thing at play, that is leaked memory, which is often underlooked. So garbage and leaked memory, they're both different. Okay. And garbage can exist without GC running. GC is garbage collection or garbage collector. Garbage is the actual trash. So like I said, you don't clear your trash every single day. You clear it once a week or something, right? When it is convenient to you. That is garbage collection. So garbage is marked at any time, but garbage collection happens based on a few criteria. So when does GC run? What is that criteria? GC is not run every frame. It's not like update. It's not run every frame. You won't clear the trash every day, right? Makes sense. It is also not done immediately. What do I mean by immediately? When we say destroy, it's not happening immediately. When we put the trash in the trash bin, we won't immediately clear the trash bin. That's what immediately means. We do it later. This GC is actually frame based and allocation pressure based. Okay. It depends on the frame and it depends on allocation pressure, meaning how important it is to clear memory. That is what allocation pressure is. Okay. Now, why does spikes appear randomly? If there's so much things that are being destroyed, or if there's so many garbage memory, then it will clear everything in one go, which will lead to allocation spikes. Okay. If there's too much garbage, it will take time to clear the garbage. I hope that makes sense. It's as simple as that. So allocation pressure is something that we can control. So instead of destroying things immediately, we can reuse objects, which is something called pooling. And then we can only destroy when we need it. Okay. So we can actually prioritize the way things are destroyed if we use our head around it, which is a lot more complex than it is. It might require a separate video or something on how to reduce allocation pressure. If you're interested, please do let me know. Okay. So I hope things are clear. And finally, let's talk about destroy. Destroy is a function, and we talked about this earlier. Destroy removes native objects. Okay. Meaning the Unity side of things, the game object, the components, all of those things. But there is a C# object that survives until GC. The C# object will be your code object. Okay. That will survive until GC. which means destroy does not allocate. This is very important. You might think destroy will cause GC. No, it does not cause GC. It can lead to GC later, or it can cause GC later. It doesn't allocate anything, but it can cause GC later, like we discussed that. So if you look at the profiler, you might not see a GC spike once you destroy, but it may happen 1 second after destroying or something like that. So the spike may happen later, and you might think that spike happens because of something than that frame in which the spike happened. But it could be because you destroyed something a few seconds earlier. So I hope that makes sense. So I know this lecture is too long, and the only thing that I'm trying to add is to add structure to this thing. And I hope this is clear. In the next lecture, we're going to simply focus on some real life examples of GC. Really simple.